Hi everyone, so it's been a while. I did a video demo, so I decided to play around with the Kagent from solo.io. So in this video I'll be just showing one of the ways you could use Kagent to do the installation via Helm, and also to do some Kubernetes based operations. So take note, this video is just for educational purposes. So there are a lot of ways that is required, that you will need to probably adjust some of the points in this video, and we will see some of those areas of improvement that we need to also look at. So I have a single node Kubernetes cluster here, and also already have the Kagent installed. So if we just do get pods, so we see, okay, so let's the right command. So we see here that you have all the controllers and the agents that are already installed. So one thing with Kagent is once you create an agent or you create an MCP server, then it will create the corresponding pod for that. So if you're interested, so I'm using micro-K8s. So it's pretty standard way of doing micro-K8s. So I'm using the Kagent CLI. So also I'm using so if you want to put your OpenAI key here, you can do that. I'll be using one of the the Sonnet LLM for this from Anthropic. So once you do this, then I'll be using the OpenAI 5G core to test this, just to see how you can use Kagent to deploy a telco network function. So if you are familiar with OAI, you realize that OAI needs an SQL database, MySQL database. So that's why, and then for the MySQL database, you will see that we already have an MCP server from this repo, but the only thing is we need to find a way to import this SQL server into Kagent. So this is the Kagent portal. So if you see here that if we look at the MCP servers, we see that these are the ones that came with the Kagent by default. So, and to connect the MySQL to use this MySQL MCP server, you will need to first of all create the secret. So the secret we have is just having like the SQL host, port user, and the remaining points. And then once you create the secrets, then you are going to inject them here, because once you do you need to give it the environment refs. So all this will be injected into this MCP server. So at the end of the day, this MCP server is actually tied to whatever connection details that you have here. So this one of the areas I said we'll discuss to see how to improve also. So ideally this is how the MCP server operates, but then you could also improve this MCP server by probably like pulling different connection strings or the authentication details from things like from Vault. So that way what you are trying to do is that you make this MCP server very flexible. So depending on your query or your prompt, then you are able to pull you're able to connect to a specific MySQL instance. But for these demo purposes, we'll just be going with what this MCP server offers by default. So let's create the MCP server. So we go to the prompt and then we do this. So if we do the get pods again, you'll see that the MCP server, MySQL MCP server, is actually being initialized and it should be up. So if we refresh this, then we see that we have the MySQL MCP server. So let's wait. We should see some tools here. Okay, let's see the logs. So let's see. We should. Yes, we see that it's downloading the. Yeah, it has already downloaded the. Okay. So yes, we can see that it's picking up the MySQL host and also the port and then the user. Okay, so let's see. I was expecting that it's going to. Yeah. Okay. Sorry. So I think it's actually took some time. So usually once you create a MCP server, it will populate the tools that are available for that MCP server. So now you see that you have the execute SQL as an MCP server. So take note, this implementation is actually outside of what this repo is doing. So what we just did is just to use the KMCP project, solution from the Kagent project to create the MySQL MCP server from there. So what we do here is actually we are using this image here for the UV, that's the Python module, and then that's the UV. So and then we are pulling those we are actually pulling the Python library, and then we are referencing the secret, like I said again. So that's that for the MCP server. So this MCP server is one that we'll be using to interact with the MCP, the OAI MySQL server. So now we also need to create an agent. So the reason we want to create a separate agent apart from the one that comes with, if we come here, we see that we have a default Kubernetes agent and Helm agent. The issue is that both of them, they are separate agents. So what we want to do is to actually create an agent that combines both tools, right? So we see that we are using the Kubernetes tools and also we are using the Helm tools, but then we are also specifying, if you see here, we are specifying the MySQL MCP server that we just created. So this agent is just to combine all the operations we want to do instead of having to move around from one agent to the other. And then also we are using the Cloud Sonnet 4 for this. So take note, if you are following this demo, this is going to incur some costs in terms of the API, the LLM APIs. So let's create we've also created the agents now. So we see that it's also coming up, and then if you do a get agent, you also see that the new agent we create is actually coming up. So it's still saying false because it's still initializing. So now we see that it's true, and if we refresh our agent, the home page, we see that we have it, and also it's connected to Cloud. So let's just do around. Then on the right hand side you will see the tools it has access to. So we can see the execute SQL as an additional tool. So let's just do a hi just to see if we are able to communicate with the agent. So yeah, so it says yeah, it's here to help with Kubernetes Helm MySQL operations. So under Kubernetes it can do this, and yeah, so it said what would we like to do. So first of all, let's just tell it to create a Helm chart. That's the MySQL, the OAI 5G core, the basic installation, and then it should create it in this namespace. The namespace should be created if it does not exist, and then it should make sure that the pods come up. So let's see, before we go there, let's the namespace exists already because I already did some tests before now, but then let's just do a watch. So we'll send this to it to do the installation for the 5G core. So breaking it down into steps, so we can see the arguments that it's going to it's going to use. It's trying to see if the namespace exists. Of course it exists, then it goes ahead to initiate the Helm installation. So it says I'll help you install. Let's see whether it has started. So we can see now that the reason it's still running is because it's expecting all the pods to be up. So only the AMF remains, so you see the AMF. So we have all the pods running. So let's see. So I think soon we should get a response. So we see. Alright, so you said installation complete successful. The summary, what was accomplished. We pull this chart. The namespace was pre-existing, so all pods are running inside this node. So let's proceed to install the Gnode B. So we do the Gnode B also. So let's see if it's also at the same time we see the Gnode B also is coming up. So it was able to detect that in this namespace this is the pod that just came up, just to distinguish it from the remaining pods. So and then for the last one we install the UE. Seems that's also coming up. Let's see the UE. Alright, so the UE also it's coming up. So all the 5G core nodes CNFs are up. So we see that the UE was the last one. And then one thing I do take note is that if your chat, if your chats are getting long, then it might go into some loops, right? So at this point let's just start another chat. So it's something I'm still trying to see how Kagent works in that aspect. It could be maybe it's not connected to, or it doesn't have some kind of memory or to increase the context length or the history. So let's just start a new chat, right? And then let's say list all the pods in the OAI 5G namespace. so we see here that it gives us a list of all the pods, and then gives us some description of those pods. So let's try. I've not tried this, but let's just ask it check the NRUE pod logs if it was able to let's say to get an IP allocation from the 5G. Well, let's see what it does with that. Okay. So now it's saying so one thing I realize, okay, the exec, it's actually showing from the result that the OAI, I mean the tunnel is actually up, which is this IP, but now it seems to be doing lots of probably going into some kind of loop. So let's see if it's able to recover. So it's doing a describe, which may not work because it's okay. I thought the describe, of course, when you describe a pod, you will not get the UAI look. But then I think it was able to resolve it. But then I think it's wasted some tokens by doing a lot of execute stuff. So yeah, but then it says yes, the NRU is successfully obtained an IP location from the 5G core. Evidence of successful IP location was this, which is quite right. And then also it was able to get the tunnel interface. Then it's also saying, okay, it was able to detect that the primary Kubernetes pod IP is this, and while the 5G PDU session IP is allocated by the 5G core, and then that's the interface. So yeah, so this is an example of how you could use something like this. But then something to check might be to see maybe the agent can be streamlined to not take call too many things at the same time. In the past, or from my tests, it's quite a bit I would say the execute command sometimes works, sometimes it does not work. So but yeah, an example of it is this, right? So if you see here that if you actually run this command, it will actually be successful, but for some reason it doesn't work there. But then the model was able to, the LLM was able to, like, okay, let me do, it's trying to go through it to see, okay, what are other things it could do. So to an extent, you might be able to like streamline the prompts, or it could essentially be something that could be wrong with the execute tool command. But all in all, this is something that you could use to kickstart your learnings on how to use something like Kagent for your 5G network. And another thing is, let's see the database connection. Let's see the content of the MySQL database. So if we say list all the tables in the database, so then it will of course know that it's going to use this tool. So we see here that it's actually able to do that. So we can see these are all the tables as per the 5G network for the so it's saying that this appears to be a 5G core network database, and you can actually use it to also run some queries also. Like I could tell it to run these queries for me. So with this, though this is a direct write, so in some cases you might have to have some policies either to see what exactly can be done or to limit what the tool can do in terms of or scope the user permissions, right? So what we can see here that it's actually added another role for this IMSI. So we see here that it says that the subscriber data has been inserted into this table. So if we tell it to show us the details of that table, so we see these are the columns, the field, and then the type of data that will be there. So some are JSON, some are like that. So that's it for that. So we can still try to see what we've actually imputed, right, to see some of the rows. So we can say show contents of the rows in table. So with this can, even though I don't know much of SQL, but then this can also kind of like just give you an overview of what is actually in the database. So you see here it says that these are all the rows, and then you see rows 1 to 6 is the UIDs up to this, and then you actually see that this is the one we just created. So it's also putting here that this is the one we just inserted also. So the only difference there, we're adding the PDU session to be of Ethernet type. So then it gives you a bit of, it's a mix of 5G subscribers with different service requirements and configurations. So this is an example of what, like, you could use the Kagent. So Kagent is streamlined into the Kubernetes ecosystem, right? You still have all that kinds of agents you could do that. Check out the Argo rollout, Cilium, Istio, the K gateway also. So even Prometheus and the observability. So, but taking into consideration what we've just done here, so we can see these are the things we were able to achieve. So like I said, the MySQL MCP server, it's something that if you don't want to create a one-on-one MCP server for each MySQL instance, so we could fine-tune this MCP server so that it will not just be using a single static binary informations, to be a bit dynamic, right? So this is something which I believe should not be too much difficult to update this Python module or create your own separate MCP server. So this has been a bit it's interesting, and it was quite fun to play around this. And you could also have a look also, and let me know what you think about how you see some of the things that have been discussed in this video. So thanks for watching, and I'll see you in the next.